Hello everyone, welcome back to TechOps tutorial. In today's session, we are going to talk about Kubernetes labels and selectors. Now, if you are working with Kubernetes, you will quickly realize that managing hundreds or even thousands of resources can get confusing. Labels and selectors are the simple yet powerful way to keep everything organized, filter resources when you need them, and even connect different components together. So let's break this down step by step in a simple and practical way. Now let's think about real world situation. Imagine you have a Kubernetes cluster running hundreds of pods without any organization. It's just a big mess. You don't know which pod is front end, which one is back end, or which belongs to production. So how do we solve this? That's where labels comes in. With labels, we can quickly find only the production pods, route traffic only to the production pods, not to dev or testing, and group the pods based on environments like dev, staging, or production. And overall, keep our cluster logically organized. In short, labels gives us a simple way to organize, filter, and connect the Kubernetes resources. So now that we know why labels are needed, let's see what they actually are. Labels in Kubernetes are just simple key value pairs that you attach to a resource like pod, services, or a deployment. For example, here we have an app as an e-commerce, tier as a front end, and environment as a production. These small tags carry a lot of meaning. They don't have to be unique, but they help us group and identify resources easily. Take this YAML example on the right. Here, our first pod called e-commerce-pod. If you notice under the metadata, we have added labels, app, e-commerce. This tells us which application is belong to. Tier frontend tells us this is a part of frontend. Environment production tells us it's running in the production environment. Now if you scroll down, here another pod e-commerce backend. This one has the same app e-commerce, tier backend, and it also in the production. So even though both pods belongs to the same application, the label help us clearly to identify one as front end and the other as a back end. That's the power of labels. They are simple, flexible tags that bring structure and meaning to your Kubernetes resources. Now let's talk about labels in services. Services in Kubernetes use label selector to decide which pod they should route the traffic. On the left side, you see the example of database service. It has a selector app equals to e-commerce and tier equals to backend. So the traffic will only go to the pods that match these labels. Here the backend pod has those labels, so it match. But the frontend pod does not match the selector, so the service ignores it. On the right side, you can see the YAML definition of the service. The selector fields tells the service which pod it should connect with. In real world scenario, this is super useful. For example, you might want your database service to connect only to a backend database pod, not a front-end pods. Some key benefits includes automatic load balancing between a matching pods, seamless detection when a pod is replaced, and service discovery via DNS within the cluster. This is how Kubernetes service makes sure traffic always go to the right pods. Next, let's look at labels in deployments. Deployments also use labels to manage the pod lifecycle. On the left side, you see the front-end deployment. It uses the label app equals to frontend in both its template and selector. That means only pod with this label will be managed by this deployment. Here the front-end pod matches, so it's managed by a deployment, but the backend pod has the different labels, so it ignored. On the right side, you can see the YAML definition of a deployment. Notice how the both selector and the template.label have app equals to frontend. This ensures consistency and helps the deployment to know which pod belongs to it. In terms of lifecycle management, deployments handle three main things: pod creation, update and rollout, and health monitoring. In pod creation, new pods are created with a defined template labels. In update and rollouts, when you roll out a new version, it only affects the pod with matching labels. And in health monitoring, if a pod with the right label becomes unhealthy, the deployment replaces it. In real world scenario, when you upgrade, the deployment will only touch the pod it created. Any unrelated pods with different labels remain safe and unaffected. That's how label help deployments, keeping things organized and under control. So far we have seen how labels help with pod, services and deployments, but labels can do a lot more than that. Let's look at some extra use of labels. First, environment separation. We can use labels like env equals to dev and env equals to staging and env equals to prod to distinguish between the environments. For example, I could run a command to only targeted production resources by filtering with -l env equals to prod. This makes it super easy to avoid touching the wrong environments. Second is version management. Labels can track different versions of an application, like version equals to v1, version equals to v2 and version equals to beta. This helps in rolling out new features gradually or running a canary deployments without affecting everyone at once. Third, team ownership. Labels can also show which team owns a resource. For example, team equals to payments for a payment service, team equals to frontend for UI components, or team equals to DevOps for infrastructure pods. This makes alerting and notification team specific, so the right people are notified when something goes wrong. And lastly, organizational benefits. Label helps with things like monitoring, billing, and even access control. For example, you can group a matrix by label, allocate cost per department, or use labels in role-based access control rules to control who can access production workloads. So overall, labels not only organize resources but also bring a structure to the whole cluster. By combining categories like environments, version, and team, you can scale your organization smoothly. Now let's talk about selectors in Kubernetes. Selectors are like filters. They help you find and manage the resource in your cluster using labels. Take a look at a diagram here. On the left, we have got a different resources, each with a labels like env equals to dev or env equals to prod. When we apply a selectors, for example, env equals to prod, it filter out everything else and only shows the matching resources. You can see those filtered ones on the right side. This makes it so much easier to find what you are looking for, especially when you are working with a large cluster. Selectors are really useful for things like finding exactly what you need from a big list of resources, connecting services to the correct pod, and deciding which pods development should manage. Here are the few real-world examples. If your operation teams wants to see only the production pods, they can run kubectl get pods -l env equals to production. For routing traffic, you can send the request only to a specific pods like Nginx using a selectors. And for monitoring, you can collect the metrics for a specific component like a database by filtering with a selectors. So in short, selectors gives you a clear, focused way to work with just a resource you care about without having to deal with everything all at once. Now that we understand what selectors are, let's look at the two main types of selectors in Kubernetes: equality based and set based. Equality based selectors are the simplest. They use equal to match the label exactly and exclamation equals to match everything except a certain labels. For example, env equals to production will select only the resource where the labels env is set to a production. Tier exclamation equals to front end will select everything except the resource with the label tier equals to front end. Here are some real world example. If you want to get all production pods, you can run kubectl get pods -l env equals to production. Or if you want to exclude front end pods, you can run kubectl get pods -l tier exclamation equals to a front end. These are very direct and easy to use, which is why they are called equality based. On the other side, we have set based selectors. These are a bit more flexible and powerful. They allow you to match labels based on list of values or even check if the label exists. Here how they work: env in prod staging means select the resource where env is either production or staging. Tier not in frontend, middleware means exclude those specific tiers. And if you just want to check if the label exists, like canary, you can simply mention the label name as a canary. Some real world use cases for this: to select admin or editor roles, you can run kubectl get pods -l role in admin, editor. Or to find the pod with specific labels like canary, just run kubectl get pods -l canary. At the bottom, there is a quick feature comparison. Equality based selectors are simple but less flexible. Set based selectors are more advanced and give you greater control. So you can think of it like this: start with equality based when you need something quick and simple, and use set based when you need more detailed filtering. Now let's see equality based selectors in action. On the top section, we have applied the filter env equals to production. As you can see, only the pods with that exact labels are highlighted in green, like frontend -prod -1, backend prod 1 and API prod 1. All the other pods that don't match are grayed out. They are not highlighted. This makes it really easy to focus only on your production pods and ignore everything else. Next, let's look at a negative selectors which use exclamation equals to. Here we have applied the filter tier not equals to frontend. This means it will exclude all pods labeled as frontend and only show the rest, like API-prod 1 and DB-prod 1. This is really helpful when you want to work with everything except a specific group. On the right side, you can see a few kubectl command example. To get all production pods, you would run kubectl get pods -l env equals to production. To get everything except frontend pods, you would use kubectl get pods -l tier not equals to frontend. And if you want to list all the production resources, not just a pods, you can run kubectl get all -l env equals to production. Here are some real world use cases. If your operational team wants to view the logs only for the production pods, they can run kubectl logs-l env equals to production --tail equals to 100. And for cleaning up test resources, you can safely delete only those test pods and service without touching other environments. kubectl delete pods, service -l env equals to test. So equality based selectors give you a quick and straightforward way to filter exactly what you need or leave out what you don't. Now let's look at set based selectors and see how they work in action. Set based selectors give you more flexibility compared to equality based one. They allow you to filter resources using in, not in, and exist operators. First, let's start with in operator. Here we have applied the filter role in admin, editor. This means it will only matches the resource where the roles is either admin or editor. In the diagram, you can see user-admin-1 and user-editor1 are highlighted in green, while the user-viewer1 is grayed out because it does not match. So the command for this would be kubectl get-l role in admin, editor. Next we have not in, which works in the opposite way. For example, stage not in staging, testing will exclude resources with those stages. Here only app prod1 and app dev1 are selected, while the app-stage1 and app test1 are left out. The command looks like kubectl get pods-l stage not in staging, testing. Then there is exits, which checks if a label is present. It does not care about the values. In the example, the filter owner selects the resource that have an owner label like service-a, service-b and service-d. The resources without the labels like service-c are left unmatched. The command is kubectl get pods-l owner. And if you want to do opposite, find resources where a label does not exist, you can use !exist. kubectl get pods-l !canary. Here are few real world use cases for set based selectors. Role based operations apply updates only to the resource with a specific role like admin or editor. Security updates skip certain environments like staging or testing during critical updates. Resource ownership. Identify resources that are missing ownership tag so nothing goes unmanaged. So set based selectors are powerful and flexible, letting you filter resources in more advanced way, especially when working with large and complex cluster. Now let's see how we can combine selectors to make our filter even more precious. At the top we have an example using multi-conditional filter. Here we have applied two filter, env equals to production, tier equals to front end. This will only match pods that meet both conditions. In the diagram you can see only the pod labeled with both production environment and front end tier are highlighted. Everything else is filtered out. The command for this looks like kubectl get pods-l environment equals to production, tier equals to front end. Think of this as a logical AND. Both conditions must be true for a pod to be selected. Now sometimes you will need to combine different selectors types equality based and set based in the same query. Here is an example. App equals to front end, environment is not equals to test, and tier in prod and staging. These filters work step by step. First we will select all front end apps, then we exclude the ones in the test environments, and finally we include only the tiers that are production or a staging. In the end, we get exactly the 3 pods we care about. On the right, you can see how this works in actual command. Using multiple conditions with commas, mixing equality and set-based selector together, and even applying them to other commands like scaling. For example, to scale only the production front-end pods, you would run kubectl scale deployments -l env equals to production tr equals to front-end -- replicas equals to 10. Here are some real-world scenarios. Target scaling: increase only the production front-end pods during the high traffic without touching other environments. Rolling updates: update non-critical services while keeping the important ones untouched. Targeted monitoring: collects the metrics only for the certain application components like checkout or a payment service. So by combining the selectors, you get a powerful way to focus only exactly the resources you need, even in large or a complex cluster. Now let's see selector in action using real-world commands and output in Kubernetes. First, we have the equality-based selector. These are used when you want to exactly match a label. For example, kubectl get pods -l env equals to production. This command lists all the pods where the env label is set to production. You can also filter by their tier. Kubectl get pods -l tier equals to frontend. This will only show the pods that belongs to the frontend tier. If you use tier not equals to frontend, it will show the opposite way. These are perfect for simple and direct matches. Next, we have the set-based selectors, which are more powerful. They let you check if the label's values is within a set of values. kubectl get pods -l env in production and staging. This shows pods running in either the production or staging environment. You can even combine this with other filters like kubectl get all -l app equals to frontend env in production and staging. So this will list all the resources related to the pod app, but only for the production and staging. Set-based selectors are very handy when you need flexible multi-value filtering. Using selectors with a kubectl, selectors can be used with many kubectl commands, not just get. For example, kubectl delete to remove a specific resource, kubectl scale the deployments, kubectl logs to view the logs of selected pods. Before running a complex command, first check the labels using kubectl get pods -show -labels. This helps you avoid mistakes, especially with delete or scale commands. Now let's see the common uses. Delete test resources, kubectl delete all -l env equals to test. Scale production, kubectl scale deploy -l env equals to prod -- replicas equals to 5. So be careful. Broad selectors can sometimes match more resources than you intend. Always test first with kubectl get before applying the changes like delete or scale. This way, selectors gives you a precious control over which resources you want to manage, whether you are viewing, scaling, or deleting them. Alright, let's quickly recap what we have learned about the Kubernetes label and selectors. Labels are basically key value pairs that we attach to resources. They don't act as unique IDs, but they help us organize, categorize, and identify the different resources easily. Selectors comes into a play when we want to filter resources by their labels. There are two main types of selectors, equality based and set based, and yes, you can also combine multiple conditions together. Now services use labels to figure out which pods they should target. This makes routing traffic much simpler and dynamic since everything works through a selector configuration. Deployments makes also use of labels. They set pod labels and rely on selectors to manage only their own pods. This is especially useful during the rolling updates or rollbacks. When you use kubectl, we can add selectors with the -l flag. It works across different resources and commands, and if the selectors is a bit complex, just wrap it in quotes. So the key takeaway here is labels and selector gives us very flexible way to organize the Kubernetes resources. A good labeling strategy is super important for managing large cluster, and combining the labels with selectors allows precise targeting, which is the foundation for services, deployments, GitOps, team ownership, and even versioning strategy. Alright, it's demo time. In this hands-on demo, I will be using Kubernetes Minikube, which I have already set up on Rocky Linux 9.2. Since we have covered cluster setup in one of my earlier tutorials, we will directly jump into working with labels and selectors. First, we will apply a YAML file to create pods with labels. After that, we will run kubectl get pods show labels, so you can clearly see the labels attached to each pod. Then we will try to filtering pods using the selectors. For example, by checking only the pods where the env equals to production and tier equals to frontend. Here is what we will practice together in this demo: creating a resource with the different labels, running label queries using kubectl selectors, exploring how services connect to a pod with the help of labels, and finally, managing the labels in a deployment, which is very useful for the updates and rollbacks. The demo files will be provided so you can easily follow along with the step by step. Let's start with the hands-on demo. I have already set up Minikube on Rocky Linux. Let's start our cluster. Minikube start driver equals to Docker. So run kubectl get nodes. Make sure we have a clean Kubernetes environment before we start. No old pods, services, or configuration interfering. So we will delete all kubectl, delete all all. We are starting with a clean Minikube cluster, so we are all on the same page. If you have already got one running, you can skip this step. Before we begin, Kubernetes lets us create a resource in two ways: imperative way using kubectl command. For example, kubectl run nginx -image nginx. This is the one way, and you can also kubectl expose pod nginx port equals to 80, and also you can provide the type cluster IP. This is quick for testing, but not something you would normally use in production. The declarative way is the YAML, which is the standard practice in real-world projects because it's reusable, can be version controlled, and works better for collaboration. In this tutorial, we will focus on the declarative YAML format since that's what you actually use in production. So now let's create a pod with labels. I will make one front-end pod and one back-end pod, both part of the e-commerce application. API version metadata name e-commerce front end We'll add labels. Production. So we'll add specification. So next what we'll do, we'll run API version v1, kind will be pod, metadata, backend, labels, let's save the file and apply it. Pod is created, kubectl get pods, kubectl get pods -- show labels. You can see the labels. As of now we can ignore this, we are main focus on the labels. This issue is for the image, it's unable to pull the image. I'm recreating it. kubectl get pods, container, it is getting created. The issue was my machine internet was not working. That's why we get this kind of issue, error, image pullback off. So once I reconnected, I deleted all the pods which are created by pods.yaml and recreated it back. All are running. Let's run show labels. Here you can see all the labels are visible. Now let's filter using equality based selectors. Get only the production pods like kubectl get pods -l will give env equals to production. It has listed only those two. Nginx is not a production. It don't have any labels env equals to production. Only e-commerce backend and e-commerce frontend has been filtered out. Get only the frontend pods. How we can get it? kubectl get pods -l tier equals to frontend. So you can also exclude the frontend pods. kubectl get pods -l tier exclamation equals to frontend. Excluding a frontend, this is the frontend pod. It has been filtered out e-commerce backend and Nginx. So next, let's try set-based selectors for more flexibility. So pods where env is prod or staging, we can filter out like kubectl get pods -l env in production staging. And we can also exclude front-end or back-end pods by using kubectl get pods. We can use the same thing, kubectl get pods -l not in front-end backend. Only Nginx is filtered out. Select the pod with a label app defined. So how we can do that? kubectl get pods -l and mention app. So this is how we can get all the outputs and we can filter it out. So services using a selector to know which pods to connect to. Let's create a backend service that connects only to the backend pods. So let's create a service YAML file. Service.yaml API version v1. We'll add kind as a service, S capital, and metadata. Here we'll give name as a backend service, and create a container selector. App will be e-commerce. Target port will be 6379, and that's it. Let's save. Service file is created. Now let's get those details. Services. This is what we have created. 6379. kubectl describe svc backend -service. So now let's create a deployment using a label. So deployments also use labels to manage the pod. Let's create a front-end deployment. YAML API version v1. Kind will be deployment. And metadata. And name will be front-end. We'll give front-end deploy. Replica to selectors. Match labels. E-commerce tier. Front-end. Let's add the template now. Containers -name nginx image nginx latest. That's it. kubectl apply -f namespace. Deployment we can add. Okay, this has been created. kubectl get deploy. kubectl get pods -l. I will filter out with app equals to e-commerce. Tier equals to front-end. Okay. Okay, this has been created now. 6 seconds ago. Earlier we are facing with error image pull issue due to my internet connection. It's not stable. So we can ignore those things as we are working on labels and selectors. Next is you can also add or change the labels dynamically on running resource. Assume I want to add a new label like kubectl label pods e-commerce version equals to v1. So label, it has been labeled. So now I want to overwrite an existing label kubectl label pods e-commerce front end staging. I will mention overwrite. So let's verify now. Kubectl get pods show labels. Here you can see I have updated e-commerce front end to, earlier it was env production, now it has been changed to a staging. And also we have added one new label named as version equals to v1 to a e-commerce front end pod this. So here you can see a new label has been attached, version equals to v1. Now let's combine the selectors for more precious filtering. Production plus front end. I will run kubectl get pods -l env equals to production tier equals to front end. And for complex example, app equals to front end but not test environment, we can write kubectl get pod list it app equals to front end e-commerce u1 exclamation equals to test here in front end comma backend. So this is how you will get the output. Now let's see the selectors with other commands. Selectors can be used with many kubectl commands like logs, scale and delete. Logs from all production pods you can get from kubectl logs -l env production tail equals to 5. So you will get the logs from all the pods which has been labeled with env equals to production. Now scale only the front end pods. Deployment -l tier equals to front end replicas equals to 3. Okay, so here I tried to scale my deployment using a label selector, but I got an error, no object passed to scale. Why did this happen? Let's check the labels on the deployment itself. Kubectl deployments -show -labels. As you can see, my deployment front end -deploy does not actually have any labels assigned to it. The labels were defined earlier were on the pods, not on the deployment objects. That's why the Kubernetes could not find a matching deployment when I use -l tier equals to front end selector. So we can also solve this. There are two ways to fix this. One, we can run kubectl scale deployments front-end -deploy replicas equals to 3, and the other option is to add the labels to the deployment itself. So we can use the selectors. So kubectl get pods kubectl label deployment front-end -deploy tier equals to front-end. We have added the labels kubectl scale deployment -l tier equals to front-end replicas equals to 3. In production, you will often scale the deployments by a name, but if you are working with multiple deployments and want to manage them together, adding a labels to the deployments themselves makes a selectors really useful. So next is, if you don't want, you can delete the test pod using kubectl delete pods -l env equals to test, as there is no resource. Here I tried to delete the pod with the label env equals to test, but the Kubernetes says no resource found. Let's check what labels our pod really have. kubectl get pods -show -labels. I will zoom out. As you can see, none of the pods are labeled with env equals to test. That's why the delete command did not match anything. If I want to delete, for example, all front-end pods in production, I would run kubectl delete pods -l env equals to production tier equals to front-end, and that would correctly match the pod running in the front-end tier of the production environment. So the key point is always double check your labels before using them in the selectors. Otherwise, Kubernetes won't find the resource you expect. That's the end of our demo. You have seen how to create a resource with labels, query them with a selectors, and use them in the service and deployments. This is the foundation for organizing the workloads in Kubernetes. If you found this demo helpful, make sure to like this video, subscribe to TechOps tutorial and hit the bell icon so you don't miss further Kubernetes tutorial, and check out our other videos on Minikube, deployment, services to improve your Kubernetes skills. Let's keep learning and mastering Kubernetes together. Thanks for watching, and I will see you in the next tutorial.